Hopefully by now you've learned how to graph linear functions in slope-intercept form. Now it's time to learn how to graph them in standard form. There are actually three types of equations for linear functions: slope-intercept form, standard form, and point-slope form. All of them will create a straight line. And in fact, all three of these equations create the exact same straight line. Standard form looks like this. You may have seen it before, where we have a number times x plus or minus a number times y equals c. Here's some examples. I might have 2x plus 3y equals 12. Or I might have 4x minus y equals negative 17. So basically, the a and the b and the c represent numbers, and the x and y stay in our equation. Now, this will only work if both a and b are not 0. Well, why? Well, check this out. If this was 0, and this was 0, and this was, 11, what would we have? We would have 0 equals 11. My x's and my y's are gone. Now it's just an incorrect equation. So how do I graph standard form? Well, there's the way that you've probably already learned, and that is put it into slope-intercept form. Let's review that. If we look at here, we need to get the x on the other side of the equation, and we also need to get rid of that -2 that's bothering y. 2 steps to do this. Just subtract 4x from both sides, and then I'll have a -2y equals a -4x plus 12. And then that's step 1. Step 2, just divide every single term, by the guy that's bothering y. And I have a y equals, that looks like a 2x minus 6. And so now it's time to graph it. So we're going to find the -6 on the y-axis, and then we're just going to go up 2 over 1, and then we're going to draw a line. There we go. But is there an easier way? Well, let me show you. When the c value can be easily divided by the a and b values, there is definitely an easier way to graph. So let me show you how. Step 1, put a 0 in for y and solve for x. Let me show you what happens when I do that. 4x minus 2 times 0 equals 12. See how that just gets rid of my y value? And then all of a sudden I have 4x equals 12. And that means that x would equal 3. And so I have the ordered pair of when x is 3 and y is 0. That is what we call the x-intercept, because it sits here on the x line. Alrighty, now I'm going to do the same thing, but this time I'm going to put a 0 in for the x value. So say 4 times 0 minus 2y equals 12. And as you can see, again, the cool thing about that is my x goes away. And then I have this -2y equals 12. Divide both by -2, and I get a y equals -6. And so my ordered pair is when x is 0, y is -6. And that is my y-intercept. And then all I have to do is draw a line through those 2 dots. It's the same line, the exact same line that we saw before. All right, let's try another one. Okay, I'm going to put the 0 in for y. So that goes away, x equals 3, and so my ordered pair is 3, 0. You see where I got those 3 and 0s from, right? I got the 0 here for the y value, and then the x equals 3, so that's where I got my ordered pair. All right, next thing, I'm going to put 0 in for x this time. 3y equals 3. That goes away. 3y equals 3, which means that y must equal 1. So when I put 0 in for x, I got a 1. All right, now it's time to plot those 2 points. 3, 0 is here. The 0, 1 is here. And now all I have to do is draw a line through them. Do you like this or not? All right, let me show you another one. I'm going to show you another way I do this. It's kind of the same thing, but it's called the cover-up method. All right, here we go. I am actually going to just take this little square and cover up this. And I get, what I get is a 2x equals 4. And so x equals what? A 2. And so I'm going to put a 2 on the x-axis. Then what I'm going to do is I'm going to move this box and cover up the x value. Do you see that equation? And so I have a negative y equals 4. Well, if negative y equals positive 4, then positive y must equal what? Negative 4. What do you think? Do you like it? I mean, I'm doing the same thing. It's like I'm putting a 0 in there. I'm just covering up each one and looking at them by themselves. All right, so let's finish graphing this. Let's see, y equals negative 4, which is here. And now all I have to do is put a line through it. Well, let's try that one more time. All right, let's try this one more time. Pause the video, try it on your own, and then come back. Here we go. I'm gonna cover up my first term here, and I see then that I have a 5x equals negative 15. And so negative 15 divided by 5 is a negative 3. My x-intercept is negative 3. And then if I cover up this, I see that I have a negative 3y equals a negative 15. And so negative 15 divided by negative 3 is a positive 5. So my y-intercept is a positive 5. Not too bad. Now it's time to draw the line. So what do you think? Do you like this method of graphing standard form, or would you like to just convert it to slope-intercept form and use that method? So here's a quick summary of what we did. Standard form is quick to graph when the C value is easily divided by both the A and B values, which is what I've shown the last several examples. However, if the C value is not easily divided, you're going to get fractions, and you might as well just convert it to slope-intercept form and graph it that way. But if it is, here we go. You put a 0 in for y, or cover up the y value, and solve for x. That will give you the x-intercept, which is just your x value and 0. Then you put a 0 in for x, or cover up the x value, and solve for y. And that'll give you the y-intercept of 0y. You plot the 2 points, you put a line through them, and you are done. All right, go graph and have some fun.